This is the last class continuation. Last class we discussed about the materials of electrical engineering, conductors, insulators, semiconductors, dielectrics and magnetic materials and special purpose materials. Now meters I will tell, two meters, very important meters. First one is ammeter, second one is voltmeter. The name itself indicates the ammeter, amperes. Amperes means this is the meter to measure current. Voltmeter means name itself voltage. So to measure the voltage. The names imply ammeters are used to measure current levels. Voltmeters are measured to potential difference between the 2 points. Ammeter an instrument designed to read the current through elements in series with the meter. So ammeter should be connected always in series to the load. Voltmeter an instrument designed to read the voltage across an element or between any 2 points in the network. So voltmeter is always connected parallel to the load. Ammeter is connected always in series to the load. These 2 points we have to remember. Next one is, last class we designed for the materials like resistance, capacitors and inductors. First one is resistor. The opposition to the flow of charge through an electric circuit called the resistance. And the units of ohms and uses the Greek letter omega. This is called the omega. Yes, it's a symbol. This is called the starting point, ending point. Always starting point, ending point should be there for any system or a component, whatever it may be. This is the resistance symbolical representation. Next, types of resistances. How many types? Fixed resistances, fixed resistors and variable resistors. Variable resistors. Fixed resistance means the resistance value is fixed. 60 ohm means 60 ohm only. 10 ohms means 10 ohm, like that. Next, this can be used for electronics, electrical circuits also they can use. Variable resistors. Variable resistors are used as rheostats. First classification, rheostat. If the 2 or 3 terminal device is used as a variable resistor, it is usually referred as rheostat. So, the one point, second point, another point will be coming. So, it will be sliding on the resistor, thereby it can be movable. 3 points are there. Next, potentiometer. Potentiometer rheostat. What it is? If the 3 terminal device is used for controlling potential levels, as then commonly called potentiometer. So the same can be used, but here we are applying the voltage input. We are taking from these 2 points voltage output. This is called potential. Same rheostat can be used as a potentiometer. Based on the application only, the name itself it is given. Like that, rheostat qualifications are there. And next one is capacitor. The symbolic representation is C. The element constructed simply of 2 conducting surface separated by the air gap is called the capacitor. So, 2 conducting parts separated by an gap. 2 plates are equal in size. If one is bigger than the other, it will indicate the battery. Same plate, same size of plates is called the capacitor. The higher potential, the higher the capacitance of a capacitor, the greater the amount of charge stored on the plates for the same applied voltage. The unit of measure applied voltage is farads. The units is farads. Named after the English scientist Michael Faraday, who did extensive research in the field. A capacitor has the capacitance of 1 farad. Capacitance of 1 farad. If the 1 coulomb of charge means 6.242 into 10 to the power of 18 electrons is deposited on a plates by the potential difference of 1 volt across its plate. So 1 farad means 1 coulomb of charge dissipated with the applied voltage of 1 volt. That is the meaning of capacitor. Once again I am reading. The capacitor has a capacitance of 1 farad. If 1 coulomb of charge means 6.242 into 10 to the power of 18 electrons is deposited on the plates by a potential difference of 1 volt across its plates. This is C. C is equal to charge by voltage. So capacitor is equal to, it is the ratio of charge to the voltage. From this, Q is equal to CV. Capacitance into voltage. Farads into voltage. Like that also you can see. Next one is remaining element is inductor. Here also capacitor types also there. Types of capacitors. Fixed capacitor. So This is called the fixed capacitor symbolic representation. Sometimes this is also called as a fixed capacitor. These two symbols can be used for the fixed capacitors. Generally, this can be used in electrical engineering. This can be used in electronics engineering. Generally, not compulsory. And next one is this is the capacitor with the variable. This is called the variable capacitor. Like that, three divisions or three types. Next one is inductor. The current flowing through a coil. This is the coil of a wire with a or without a core establishes a magnetic field through and surrounding circuit. So it will establish a magnetic field with or without core. Core means iron. This is called the inductor. This component of rather simple construction is called the inductor. It is referred as a coil. Its inductance level determines the strength of the magnetic field around the coil due to the applied current. So this is applied current. For capacitor means voltage, resistance means voltage applied. For inductor is formed by applying current. The higher the inductance level, the greater strength of the magnetic field. Inductance are designed to set up a strong magnetic field linking the unit, whereas capacitors are designed to set up a strong electric field between the plates. The symbolic representation is L. Units are henries. Henries. 1 Henry of inductance level that will establish a 1 volt across the coil due to the current of 1 ampere per second through the coil. This is the inductance. Here also types are there. This is called the inductor, air core inductor. Next one is ferromagnetic inductor. So, take on iron, wound on the conductors. This is also iron core. If we remove this is a symbolic representation also, like that also you can use. The above also they will use. It will indicate the core. This is called core, iron core inductance. Next one is tapped inductance. Similarly, resistance also tappings are there, but generally it can be used. This is called one tap, second tap, three taps will be used. This is called tapped inductance. Next is variable inductance. The tapped inductance also like this also you can write. The both are two are same. Like that, four categories. Next class we are going to discuss about the Ohm's law. Okay, please subscribe my channel. So next class, how the Ohm's law will be converted and how the from resistance, how the Ohm's law related to resistance, how the remaining classes, how it will be related to the parameters also we are going to discuss. Okay.